chief guest, Professor M.N. Deshmukh sir, our chief speaker, Mr. Vikesh Pandey, present excellencies, fellow faculties, research scholars and students. I, Tanu Dua, on behalf of Satyug Darshan Institute of Engineering and Technology, welcome you all on the fifth and last day of International Symposium on Data Science. I hope these past 4 days helped us to advance on the journey of learning. But it does not stop here. Further, to enhance our knowledge on data science, I feel privileged to introduce the speaker of the day, Mr. Vikesh Pandey, an AI ML specialist solution architect at Amazon Web Services, Sweden. Mr. Vikesh Pandey has a decade of extensive experience in software industry. He has worked with the techno giants as technology lead and senior associates at Negero and Sapient. He has also worked with Infosys for the product maintenance and development. He is proficient in machine learning at AWS, microservices, REST, Maven, IntelliJ IDEA. He is also well versed in data analytics, Spring and Hibernate framework, and MongoDB. He holds 5 different certifications from AWS with specialty in machine learning, system operation administrator, solution architect, and developer. Let us all welcome our speaker, Mr. Vikesh Pandey, to share his precious knowledge and experience with all of us. Over to you, sir.
Thank you. Thank you for the nice introduction. Okay, so the annotations have been disabled. There's a slight issue in the way the PowerPoint is working. It's behaving a bit weird. So I think I'll settle down with this view. I hope it's visible to everybody. Is the screen visible to everyone?
Yes, sir, it is visible.
Thank you. Okay, so let's get started. First of all, I'd just like to introduce myself briefly and also walk you through the agenda. So the topic of today's discussion is around how we can build scalable machine learning solutions while working in enterprise projects and working in industries. So my idea of presenting this talk is to bring all of that experience in this 1 hour odd time to give you some insights as to what kind of solutions different companies have been using to build machine learning solutions. What are some of the most popular tools and components around that? Some reference architectures, and we will also touch a bit about how we can deploy machine learning and maintain machine learning solutions at scale. So let's get started. Though I think that the speaker already introduced me, and thanks for that. But I would just like to tell you about a bit of my other side. So I have more than a decade of experience working in the software industry. Currently, I'm living in Stockholm, Sweden. It's been a couple of years since I moved here. Before that, I've been working all over my career in India. I started my career as a Java developer. I love working in Java, but lately Python has started enticing me more and more, and I'm trying to shift my loyalties towards Python. One of the reasons of that is also because Python comes so natural to machine learning and the whole ecosystem around machine learning. So it was also a sort of my job direction or my career direction that I wanted to move into this direction. But this is my opinion. So do not take this as an opinion as Java is going away anytime soon. Java is going to stay. It's just that Python is quite neck to neck nowadays with Java. I'm quite passionate about this field of artificial intelligence and machine learning. It's been a few years since I started diving deep into this particular field. And the whole idea and the whole reason I moved towards this particular field is that the influence of machine learning is going to be everywhere in the world around us. It is already in a lot of the places and in a lot of the things we do. Every software we interact with, there's a very good chance that there is some sort of artificial intelligence built into it. I mean, to tell you a very simple thing, if you just open your mobile phone and you type a message, it gives you some suggestions, right? Those suggestions are also powered by machine learning algorithms and models at the back end. I'm a foodie by choice. I love food, and no marks for guessing that I love Indian food. So that's what my weekends were before this COVID-19 pandemic hit. I used to visit every other Indian restaurant around in Stockholm and try the cuisines. And I also thought of writing a food blog sometime once I have a good experience about the different reviews of different restaurants around that. I love blogging. That's what I do in my spare time, and I write some technology blogs on my website, which is hosted on GitHub. Apart from that, I also write blogs on Medium, DZone, to name a few. So that was about me. Now let's get to know you better. So I've prepared a fun quiz just to get the audience here. So you can see the URL here or the QR code here. So I would request every one of you, all the participants, to either hit this URL or just scan the QR code from your mobile phone, and it will bring you to a survey which might not be started yet because I will be controlling the survey from the backend. But I would give you a few seconds to just sign up on this survey. And while you do that, I would just set the tone of today's discussion. I love having informal discussions and informal seminars and webinars. So this is also going to be a bit informal. There would be some dry humor as well here and there. So if you don't like that, apologies for that in advance, but we'll try to keep it informal and we'll try to have fun. So let me see. Let me also bring up the results screen here. So whatever responses you're going to record, those responses will be listed here. I hope everybody has either scanned the QR code or entered the URL by now. So let's start the quiz. So the first question is, are you a faculty, are you a student, or you think that titles don't apply to you and you are just an awesome learner? I'll give you guys a few seconds to register your vote. I think we have 164 participants. Wow, that's a lot. I expect a huge number popping up here. We still have very few votes here. I'm quite excited by the fact that we have a lot of students here. It's going to be fun. And there are some humble geeks here who think the titles don't apply to them. I respect you guys. I'm also one of them. Okay, the student bar keeps raising. We have only 3 faculties. I'm a bit surprised by that fact.
The participants are requesting for URL again.
Okay, let me share the presentation then. So here's the URL. It's a very brief URL, etc.ch/G8V and F capital. Okay, let me shift to the results screen and see what's happening there. Still very few votes. I'll give you guys a few more seconds. Let's be quick here. Let's not spend too much time. I just wanted to get to know the audience, the flavor of the audience. That's why I prepared a few questions. It's 4 to 5 questions. Okay, now we have some competition from faculty. Okay, I think I'm gonna stop this here and move to the next question. And again, please be fast. Please, it's just a click of button and just hit submit. It should not take much time. So please be quick on this. So this is the first question. So I think we have majority of students here. We have a good mix of faculty and some humble geeks here. It's going to be fun. So I'm moving to the next question. So what is your exposure to machine learning? Are you a beginner? Are you an intermediate? Are you an expert? Or you are a veteran that you dream about neural networks in daylight? Okay, we have majority of beginners to ML. And the reason of asking this question is that so that I can frame the discussion forward, and I will try to just brush up on the basics as well and not expect the audience to know everything. That's the whole intent of this question. I'll give you guys 5 more seconds to register your votes. Okay, so beginner profile wins hands down. We have some intermediate, that's good to know. I hope I will be able to provide you some extended knowledge here. Let's move to the next question. Yeah, this is the fun question. You are joining this session because you are curious about machine learning, or you want to know about how industries does it, or you want to take on ML as a career option, or you are just getting bored and wanted to do something excited on the weekend and you decided on joining this session. There we go. This looks nice. I like some competition in the options. We have a lot of curious learners who also, I think, intend to be beginners. And we have pretty much a tie on the rest of the three options, which is good. I like honest audience, and I like that people have chosen the option that they had nothing better to do on the weekend and they thought this would be fun. Thank you everybody for registering your votes. And I have one more question. This has nothing to do with today's session, but like I said, I love to be informal. So this is going to be fun and there is no right answer. If I had to choose one thing in life, I would choose money, success, love, or just sleeping and doing nothing. Let's see how many honest people we have here. We have a lot of humble souls who just want love in life and not food, not money, not success. All the best to you guys. No offense. And we have some brutally honest people here who just want to sleep and do nothing. Huge respect for you guys. Surprisingly, when I put this question in my other webinars, money tends to be the biggest part here, but I think we have people who have found the meaning of life, that money is not everything. That's good to know. Okay, that was a good mix of responses, and thanks for registering your responses. And now I know you much better than I was earlier. So let's get onto some serious stuff, though we'll still keep it fun. I take fun very seriously, so I would expect the same from everybody. So first of all, like we have some beginners in the audience as well. So I would try to just set the level, bring the level to the same parity, just to bring all the audience at the same level. When we talk about machine learning, we have broadly three different types of machine learning. So we have supervised learning, we have unsupervised learning, and we have reinforcement learning. So supervised learning is a learning technique in which you have some data, you have some interactions data. For example, you bought a shoe on X website on this particular day. This is the complete data point. And then you provide this data to a machine learning algorithm, and the algorithm gets trained on your data. And then you have a model. So this kind of machine learning approach needs labeled data. It needs real factual data on which it can get trained. And you need to tell what to train about. You need to tell, let's say, for example, let's take a very, very simple example that you are working for a banking organization, and the banking, your manager or your superiors have told you to build a machine learning model to detect fraud. And so the objective of this learning problem is very simple. It's either or no fraud. So you take a bunch of transactions, you train your machine learning model on it, and then when a new data point comes in, when a new interaction comes in, you just want to know whether this transaction qualifies to be a fraud or not fraud. So you already told the machine learning algorithm what is fraud and what is not fraud, and it learned on that particular data. That's supervised learning. When we talk about unsupervised learning is a learning technique in which the data is not labeled. You won't tell the machine which is fraud and which is not fraud, but you tell a bunch of other contextual information around those data points to the machine learning algorithm, and the algorithm will automatically find patterns in the data. For example, if I have lots and lots and lots of customer data, I provide all of that customer data to a machine learning problem. I don't tell which customer is a premium customer or which customer wants to buy X or Y or whatever. I just give some data to the machine learning algorithm, and then the unsupervised learning algorithm will automatically cluster the customers, that these are low spend customers, these are high spend customers, these are the customers who are more loyal to your website, these are the customers who are likely to go away from your website. So it will find clusters and patterns in your data automatically. That's unsupervised learning. The third and the most interesting one is reinforcement learning. Reinforcement learning is a learning technique in which you don't tell the machine what is right, what is wrong. You just tell the machine about the end goal. And then you just ask the machine to take an action on a particular problem. If that action contributes to increasing the percentage of success of achieving the final destination, then the algorithm gets a reward. And if the step which the machine has taken decreases the possibility or the probability of achieving the final destination, then it gets a punishment. So it's a reward and punishment game, which is the basic underlying principle for reinforcement learning. So all the fancy news which you read in the tech blog space, which is about self-driving cars, robots, all of those are application of reinforcement learning. I hope this gives you a good understanding of 3 different types of learning. So let's move ahead. Occasionally, I will also be observing the chat box if there are any questions, but I will make sure that we spend some time at the end to have a Q&A as well. So first of all, let's understand how actually is this field is evolving. So as some of you may already be aware that machine learning has stayed in the area of research for many years. It actually exploded into the real world scenarios. So after the Y2K boom happened, after the internet boom happened, and things actually started taking off after 2005 or between 5 or 10, I would say. It's basically the time when these social media giants popping up, and we had the mobile phones in everybody's hand, and the internet data rates just plummeted to the historical low point. So all of these contributed to generating a lot of data, and that's when these machine learning concepts and these research papers actually started getting implemented into the real life. This actually worked good for a while, and then the existing algorithms and the existing solution which we have, they started falling short of dealing with this huge amount of data. I mean, for example, to give you a fact, this is a 2019 fact, not even a 2020 fact, that in 2019, in every minute, there is almost 50 petabytes of data being generated every minute. So we are looking at a huge scale of data, and the existing machine learning algorithms just started falling flat to solve these problems. And then came the neural networks. The cool thing, so the neural networks work in a very different way than a traditional machine learning algorithm. And these neural networks are huge, are extremely scalable. You can make them really complex. They just need good hardware to run upon, and that's pretty much it. And neural networks actually change the whole game. Today, I can say that the future of machine learning lies in the neural networks. So where are we sitting right now? Like I said, this has been in research for many years, and we are starting to come out of it. So where actually we are right now? Let me break the bubble. So though this field is almost everywhere, but we are still scratching the surface of it. There are still a lot of unknowns. There are still a lot of undefined things, and there are still a lot of things still in research. I mean, for example, if you observe archive.org, the research paper or website, which is hosted by Cornell University, you will see new research papers popping up almost every day there. So there is still a lot of research going on. So it's not very mature. It's not as mature as web development has been for many years. There is no gold standard or silver bullet. So for example, when you talk about the traditional programming language or the traditional software development lifecycle approach, you follow a certain pattern, and you frame certain rules which tell you that, okay, if I have to write a Java class, it will be written in this way. If I have to write a C++ project, it will be written in this way. But in machine learning, there's literally no gold standard. There is no reference guide. It all depends. And that's something which you will hear frustratingly from anybody who is an ML expert, that whatever question you pose to them, the first answer you will get is that it depends. And actually it is true. It depends on the data. It depends upon the use case. It depends upon the algorithm. It depends upon the parameters. There are so many moving parts when we solve a machine learning problem. There is no single gold standard guide. Okay, so when we talk about the enterprise adoption, what is happening there? Like I already gave you a hint of the fact that machine learning is very, very complex. It gets very complex. You can start simple, but the moment you put this into an organization as big as Volvo Corporation or Coca-Cola or Netflix, things get really, really messy. The traditional software development lifecycle models, they just don't work with the machine learning when you work with machine learning projects. So you need to find newer ways to work with this particular space. Finding bugs is even harder because when you work with a traditional software, which is let's say a website or web application, so you have a defined phase, right? You develop something, you throw it to the testers, they test it, they find bugs, they report the bugs. Until the time the bugs are not fixed, you don't move to production. You don't make your software live, right? But with machine learning, the things change because you have historical data on which you trained a machine learning model, and then the real-time data, the real-world data, can actually be very, very different from the data which the machine learning model was trained upon. I mean, to give you an example, before recession hit, the 2008 recession hit us, there was literally no concept of shared cabs like Ola and Uber. It was in very, very minimal space. And today it's the go solution. So if I'm collecting the data points of how a consumer is spending their money, in 2009, there was very less data about a consumer which is being spent on taxi rides. But today, if you're working in a metropolitan city, then there would be a good amount of expenditure contributing to that category. So the data changes. We will talk about how we'll solve that problem as well in the upcoming slides. It's highly iterative. That's again contributing to the previous example I gave, that you need to, I mean, for example, if you create a login page for a web application, it works and it will forever work if you build it right once. But in ML space, nothing is permanent. You have to retrain your model. You have to add new parameters because the data changes, consumer behavior changes, other properties of the algorithms changes. So there's a lot of moving parts. So you need to iterate upon the same thing again and again. It's highly iterative process. There are multiple teams involved. I will talk about that as well, where which team actually pitches in. And there's a huge scarcity of machine learning engineers nowadays. So how do we actually do this? How to do ML at enterprise scale? Let me also look at the chat box if I can to see if there's any question. Zoom is behaving a bit weird with me. I can't see the chat box. Never mind, we will take up the questions probably at the end of the session as well. Moving on. So first thing first, if you're working in an enterprise project, you collectively with your team, everybody who's working in this project should sit in a room and answer these questions. If you don't do that, do this activity of answering these questions, there's a very good chance that you're going to fail. The first thing is, what are you trying to do? This is very generic. This is something which you do for traditional software development projects as well. You define the objective, good enough. The second thing is frame the business problem as a machine learning problem. That's very, very, very important. It sounds philosophical, but I have seen machine learning projects failing because they did not get this right. Let me give an example. So for example, let's say you are working for a recruitment agency and you want to increase the chances of selecting a CV so that that particular person gets hired. So this, what I just told you, is basically a business problem. Now you need to convert this business problem into a machine learning problem. So you need to define that, okay, I need to have an accuracy of 0.7, between 0.7 to 0.9. I need to have a different hyperparameter tuners. I mean, I need to know more about the machine learning space as well as the domain space to actually map the business problem to the machine learning problem. And what is my outcome? My outcome is to find a probability. So it's a numerical problem. So it's a regression problem. So you see, you make a path. You make a path from the business problem to the ML problem. The third thing is data. I cannot stress more about this fact that how important data is. And I think I can say this with enough confidence that your machine learning solution or your machine learning model is only going to be as good as the data. If your data is not good, your machine learning model will not work. So you need to spend a lot of time in getting the data right. What is the data? Where it is coming from? How does it look like? And you should know when to stop training your model. That's also very important. We will also touch upon this, how to do that. So you need to know when your machine learning model is ready to be deployed in production. It will not stop it by itself. You need to tell when to stop. And you should also know when not to use machine learning. Let me give an example. So if you have a black bag in which you have red balls and blue balls, okay? And you want to use machine learning to predict or increase the possibility of selecting a red ball or a blue ball. Now, this is a pure mathematics problem because no matter what you do, no matter what sophisticated machine learning algorithm you use, you will never be able to increase the success probability beyond 50% because it's either going to be red or going to be blue. And 50% accuracy is a terrible, terrible, terrible performance for machine learning model, and you will never deploy that model in production. So you see, so you need to always take this, you need to always play the devil's advocate as well to figure out whether this particular problem is actually a machine learning problem. And where to do it, if you get it wrong, it is going to hurt your finances really bad because when we talk about neural networks, you need super high powered GPU machines to do really, really complex mathematics calculations. Machines needs lots and lots of power and memory to do that. And setting that on your own is not cheap. We will see how we can solve that as well. And this is how we solve it. So the next question which you need to ask is cloud or no cloud? Since I work in cloud space, so you might find me biased, but I will not try to be biased. Instead, I will try to give you the reasons, and you decide by yourself if you think it makes sense or not. So if you don't use cloud for building your machine learning solution, you have complete autonomy on the hardware because you purchase the hardware, you set up the network cables, you set up the software and the hardware and everything around that. You set up the power cables, you set up the air conditioning, you hire security staff to protect your computers. You also protect it from different natural disasters like floods, etc. You also spend money on doing security audits, but you have complete autonomy. And this whole process is very slow. For example, even in 2020, I'm stating this as a fact, that even if you're trying to purchase a high-powered GPU machine for enterprise, it may take up to 3 months to get it provisioned. Now, would you want to wait for 3 months because your competitors will just fly past you and will build a better solution in those 3 months? It's costly because GPU machines and the hardware, because you need so much of hardware and memory that it's going to hurt your finances at some point because you're purchasing it as a retail guy or a retail company or just one company. Your total cost of ownership increases. When we talk about total cost of ownership, it includes all the things which I talked about. It's not only about purchasing the physical hardware, it's about the network cables, it's about the manpower, it's about the air conditioning, it's about the land space where you will install these machines and put these machines. Everything is total cost of ownership. It's less secure, I will tell you how. And there is no community learning because you only know what you are doing. Your competitors are never going to share what they're doing with you, right? So you just live in your own world. Instead of, on the other hand, if you move to cloud, there's less autonomy, obviously, because you don't you don't buy the hardware by yourself. You let the cloud provider like Amazon Web Services or Google Cloud Platform or Microsoft Azure to do that for you. But the provisioning is super fast. For example, if you want to spin up a huge G-powered machine in AWS Cloud, it'll take you a few minutes, probably 5 minutes to just spin it up. So 90 days to 5 minutes. Hope you can see the contrast. It's cheaper. And I will tell you why it is cheaper. It's cheaper because when these cloud vendors, they buy these hardwares at such a huge scale. For example, I'm a cloud vendor and I am purchasing 50,000 GPU machines. So I get bulk orders and I get bulk discounts, which you will not get if you're building it for yourself because you're just one customer. You will never buy 50,000 GPU machines in once. It's super secure because all of the cloud vendors go through multiple third-party audits, and we are talking about all those security audits which you can think of, from PCI DSS to ISO to whatnot. So, for example, AWS has more than 50 to 60 certification and accreditations to its belt that can prove that the hardware and the whole solution is secure. And there's excellent community learning. We also share the learnings from one customer to other with our customers so that every customer can learn from each other. So I think cloud wins hands down, but I will leave that to you to also build your opinion. So when we talk about doing the machine learning, we cannot just get started. We need to do a lot of preparation for it. First of all, in most of the scenarios in industry solutions, the data pipeline acts as an input to the machine learning solution or the machine learning algorithm. And the data pipeline can get really complex. This is probably the simplest architecture I could draw. So let me just walk you through it. So you may have a bunch of different applications, right? This can be social media tweets. This can be application logs. This can be data which is sitting in the relational database systems. This can be any data which you want your machine learning model to have or to know. So you have all the data sources listed here on this side. Then you have a data lake. So a data lake is you can just think of it as a point where you can dump all of that data. And this data lake can get really, really huge. We will look at these components, all of these components one by one. So this is just, I will just give you a brief and then we'll dive deeper into each of these components. So data lake is just one point where you dump all the data. This data has no structure because logs can be just plain string. Social media feeds can be plain string. Instead, this data can be tabular, right? So you have different mix of data. You just dump all of the data here without thinking. Then you have data cataloging step where you actually define a schema for the data, define a structure for the data. Once you have defined the structure, then you have three options based on what the data is. Like I said, it depends. So it depends upon what you're trying to do and what your data is. Depending upon that, you either perform extract, transform, load step in which you change the representation of the data, or you just do massive parallel processing across thousands and thousands of machines. If you have exabytes of data and you just want to remove some columns out of it, or cleans the data, remove noise, change the representation. So ETL is a bit lightweight and data processing is for massive parallel processing, if that's what you want to do. Or if you want to just use this schema to run some SQLite queries to get the refined data. So it's up to you how you want to refine it. All these three steps actually process and refine the data. And once you have the process data ready, then this data can actually be fed to the machine learning space. So let's look at all of these components and what different industry standard solutions are available for these components. Before we do that, I will just, so from here, from the process data, the next step actually goes into this particular diagram. I will be referring to this diagram quite often in this presentation, but the whole point is that you have ingested the data, then you do some data preparation. We will see how we do that. And after that, you train your model and you tune your model. How do you tune it? We will come to that later, but you can see that this is a big box, right, which says ML model training. So in the whole training cycle, the model will keep getting trained and keep getting tuned. This happens continuously and iteratively. Once you're satisfied with the model's performance, you provide a test data set to evaluate the performance of the model. If the evaluation passes, then you deploy this model to the real world. And here, if you see, when you evaluate the model, if the model is not good enough, then you again retrain the model. Even on deployment, you also monitor the solution. And if you see that the consumer behaviors are shifting and the model's performance is going down, then you again retrain it. There would be also an error coming from deployment/monitoring box back to the retraining. So you see this whole cycle is continuous and iterative. That's why I said that this process is hugely iterative. So the first step of the prerequisites to ML is a data lake. It's basically, you can think of it as a centralized repository where you store all of your data. It can be structured data, which is like coming from RDBMS solutions, or it can be unstructured data, which may be logs, feeds, sensor data, whatnot. It can be literally anything. And you just store the data as is. And these data lakes can get really, really big. It can go to petabytes. I mean, we don't talk about gigabytes when we talk about data analysis and machine learning because that's too small. So it's petabytes, exabytes, and even in some cases, yottabytes of data. So it can be lots and lots of data. Okay, so what are the tools for designing a data lake? One of the most popular de facto standards for building a data lake is AWS S3. S3 is an Amazon Web Services service, and lots and lots of AWS customers use S3 as the go-to solution or the go-to service to build the data lake. The reason is that S3 is hugely scalable. It can store literally unlimited amount of data, and you can read this line on the official website of S3 as well. It says it can store literally unlimited amount of data. There's no upper threshold to it. The other solution is AWS Lake Formation, which is an advanced version of building a data lake. Because when you build data lake, you need to do a lot of stuff. You need to dump all the data. You need to define administrative rules as to who sees what data, right? So Lake Formation provides you more of an opinionated view, where it will give you some predefined rules and rule sets already, and you can just focus on the data rather than building those rules by yourself. And there are similar offerings from other cloud providers as well. And non-cloud data lake is just a recipe for disaster. I would never, ever advise a customer to do that because, like I said, storing exabytes of data by your own expense, managing that data lake infrastructure by yourself is just going to kill your finances. So it's always advisable to use cloud for building a data lake. The next step is data cataloging, as we saw in this diagram. So we covered data lake. The next one is data cataloging. So when we talk about data cataloging, the whole idea is to make sense of the unstructured data which is sitting in the data lake. And as you can imagine, we need somebody who knows what this data is all about. For example, if you are working for an automotive organization and you are asked to build a solution for a bank, and you are asked to do this particular step, you are going to screw it up because you don't have any idea of what are the nuances. How does the financial data look like? Because you have been working in automotive industry. So you need domain experts to actually understand the data and build a schema around the data. You can think of the schema as a schema which you create in relational data. You can think, I will give you a very loose analogy. Don't take my words for it, but a very loose analogy can be that you define a table basically. So you create a table for the data which is sitting in the data lake so that we can read the data which is sitting in the data lake. That's our whole objective, that we want this unstructured data to be read. And to read it, you need to define a structure for it. And that's what we do in data catalog. Okay, so far so good. So what are the data catalog solutions? So the most popular one is Apache Hive. It's extremely popular across industry and across different customers and different verticals. It's very simple to use. It's open source, and I think that's why a lot of people jump on it. But you also need to install it and manage it by yourself, because you might need to apply patches on this Apache Hive data store. You might need to protect it from different security endpoints, right? So you need to do all of that by yourself. So either you can use the Apache Hive data cataloging solution by yourself, or you can use one of the managed services. Like for example, AWS has Glue. Glue is a data cataloging / ETL solution where you can just throw some data to Glue, and Glue is so advanced that it will automatically discover schema of your data. You don't even need to define it. It's so cool. So that's something which is done by Glue, and that makes Glue a very popular solution in this particular space. There's also another solution which is Athena. So if you don't like the things which have been automatically discovered by Glue, then you can use Amazon Athena to build a schema by yourself. You define, literally you write a SQL statement saying, create external schema, so and so. So you create the schema by yourself. And for this, you need a lot of domain expertise. So that option is also there, and you can use Amazon Athena, which is another service of AWS, which can be used. And there are some other solutions as well, like Data Hero is very popular across different customers and different industries, and that also can be used. So we did the cataloging. The next step is doing ETL, extract, transform, load. And why do we need to do that? Let's understand that first. So when we talk about this particular step, the challenges with real data are that generally this data is not in a state which can be consumed directly by the applications. The data has a lot of noise. Noise means that there are some data points which are not relevant. For example, I'll just give you a very simple example. Let's say Zoom, for example, is collecting data. I hope it is not, but I'm just giving an example that Zoom is collecting data of all the chats which happen in a meeting. So for example, we have 225 participants in this meeting. And if every participant says hi, so you have 225 messages, which are just noise, which do not tell anything to Zoom, anything relevant to the Zoom. But if you have discussions going on in the chat box, if you have questions, then Zoom can learn from that data. So the hi is basically noise, which you need to remove. You also might need to convert the representation of the data. For example, data is in CSV files, which is basically a comma separated format. So if it's in CSV and you want to convert into a format which is better consumable by the data analysis steps, and that format can be Parquet. If you haven't heard of this format, it's a very popular format which is used by different customers. So if you want to convert the data from CSV format to Parquet format before you feed it into the further steps, then that is something which you do in this extract, transform, load step. So the whole idea is that you extract the data from the data lake, you transform the data, like converting the CSV to Parquet, and then you load it back somewhere. Now this somewhere can be a processed data store, it can be a data warehouse, it can be any other data processing solution as well, it depends. So this is what we do in the ETL part. And when we talk about the different ETL tools, like I told you earlier, that Glue is data cataloging / ETL tool, and it provides very nice, again, this is, let me rephrase this. So the whole advantage of using any managed service in the cloud is one, that you don't manage the infrastructure by yourself. It's all managed by the cloud providers. And these services also tend to be a bit opinionated, so that you don't have to even do some things at times. For example, Glue will automatically read your data, will automatically create a schema for it, and it also has automated options. You can just select it from a drop-down saying convert from CSV to Parquet and submit, and boom. It will take a few minutes and you have a Parquet file ready, converted from the CSV. So you get a lot of managed experience when you use these ETL solutions. Matillion is extremely popular, extremely popular, and I have used it myself and I was amazed by the user experience. It has a nice drag and drop functionality, so you can drag components and steps and it will automatically generate all the code at the backend. Matillion is extremely popular. Informatica has been there for a very long time in the industry. It had its winter time when Informatica literally lost its sheen because other advanced tools were so smart that they just outpaced Informatica. But now it is again gaining popularity. And Talent and SAS are also a couple of options which will pop up whenever you have an ETL discussion with your team or your customers. So if I take you back, if you are lost, if I take you back, so we covered the data lake, we covered the data cataloging, we covered the ETL. Now we will look at this part. I've intentionally skipped the data warehousing because that will require in its own discussion. So we'll focus on this particular step now, data processing. And after this, we'll have our data ready. You also see that you can either directly process the data, or you can also take the ETL output as an input to the data processing, because you can do lightweight transformations here, and all the heavyweight transformations which require a lot of processing can be done in this particular step. So you can either feed it directly or feed it from here. It depends upon your data. So taking you back to where we were, data pre-processing. Like I just said, ETL is good for lightweight transformations, but if you have to do massive parallel processing, if you have petabytes and petabytes of data and you want to do some linear transformations or some singular transformations or some cosine transformations on the data, how do you do that? If you try to do that traditionally, it's going to take months or even years in some cases. So you need smarter ways to process this petabytes or exabytes of data to do this quickly. And even if you try to do that by yourself, let's say you had the courage of buying 50,000 servers to do this parallel processing. And I'm not making up this number. We have use cases where the organizations are using thousands and thousands of servers to process the data. So it can go really big. So even if you have purchased the servers, how do you manage them? You need to run each of the server. You need to connect each of the server with each other. Just think of the amount of the networking cables you would need to connect all of these thousands of machines together. It's a lot of work. So that's why you look for some smarter ways to do this. And this is how we do it. Apache Hadoop, I would say hands down, this is the go-to solution, and it heavily dominates this particular step. I mean, if you talk to any big data engineer and you talk about data processing step, I'm 100% sure the first response you will hear from them is about Apache Hadoop, that let's use Apache Hadoop. Apache Hadoop is a big ecosystem. It's an open source solution. It has lots and lots and lots of functionalities, and I'll not go deep into that because that will eat up the whole hour. But the whole idea is that Hadoop provides you with that capability of doing distributed and parallel processing on commodity servers. And it provides you with a managed experience so that you don't have to manage all the nitty-gritties of software and patching and connecting. It will do all of that by yourself. You just need to install the Hadoop software on that particular setup. Still, this is a lot of work, and that's why we have this and this, Amazon EMR and Hortonworks. These provide you with a managed experience of Apache Hadoop. So if you, for example, if you use EMR, which is Elastic Map Reduce, that's the full form of it, you just go to the console, you select a Hadoop cluster, you provide the number of instances, number of machines you need, and you hit submit. That's pretty much it. And it will take a few minutes and it will set up the whole cluster for you. So that's how easy it becomes when you use a cloud-enabled solution. This is also a service which is available in AWS cloud. Apart from that, you can also use Apache Spark if you like. But again, for Apache Spark as well, there are some managed solutions available on AWS cloud which can be used. Or there are some third-party solutions as well which provide a managed Apache Spark processing solution. Hortonworks is also doing the same thing. It is also running Apache Hadoop underneath, and it provides you with a managed experience of Hadoop cluster. So like I said, I mean, Hadoop is the one which is dominating heavily about this solution. And I think this is the go-to way. Okay, so now we have the process data. Now the first thing which we need to do is about the data analysis and preparation. You have the data ready, right? But you need to understand that machine learning does not really understand the data. It understands vectors, it understands tensors, which is also, you can think of it as a multi-dimensional array. So it understands arrays, it understands vectors, it understands numbers. It needs to do really complex differential calculations and triple integration calculations. So all of the things which you actually study in your college actually is used there. I mean, it was a big revelation for me because I'll be very honest with you. When I studied these things, I always was very curious as to why am I actually studying this? Why am I studying differentiation and integration? Where are actually these being used? And they all are used in this machine learning computation algorithms, basically. And why do you need this? Because what if your data is heavily skewed? What do you mean by that? For example, you may have a data set. Let's talk about the same fraud, not fraud data set. You have a huge data set. How often you have a fraud and how often you have a not fraud? For example, for most of the transactions in the data set will be not fraud. There would be only once in a while transaction which would be detected as or which would be actually a fraud. So if you have 10,000 data points in the data set, it might be possible that 950 of them are saying no fraud, and only 50 of them are saying fraud. Now, if you train your machine learning model on this, it will not be performing very well because it does not know enough about the fraud use cases. You need to give it more data about the fraud use cases. So that's what you do in this data preparation / feature engineering step where you actually do all of these calculations. You also synthetically generate some data sometimes. What if the true negatives are detected as outliers? The same thing which I just told you. If you have 950 data points which are just saying not fraud, you have a machine learning model, and the next time a data point comes to it, even if it's a fraud, this model might not flag it because it might think that this is just one of exception. It's an outlier. A lot of columns may have missing values. It happens quite often. For example, if you're taking a dump of a relational database solution, it's very a good possibility that there would be a lot of optional columns which will have missing values. And those optional columns may have a lot of significance about telling about the data, right? For example, if you have an optional column of address in some database, it's good enough for your application, but for machine learning, it needs to know the context where the user is living. It needs to know about the data. So it might be possible that a lot of columns are having missing values and they have unrelated values as well, or the data is just too sparsely distributed. There are a lot of missing points in the data. You need to fix all of these parts, and you fix them using some feature engineering solutions and data analysis solutions like NumPy and Pandas. These are the go-to solution in data science category where you actually use these tools. Just a time check. I mean, I still have some more content to run. So if you can accommodate with me for 10 minutes more past 7 p.m., that would be great. I will just wrap all the content around that. So yeah, coming back to this particular step. So the NumPy and Panda is basically libraries which you can use to build your data science, build your analysis, understand the data, use Matplotlib and Seaborn. These are the libraries which you can use to create these kind of graphs. So this is just a visual representation of your data. Now this gives you a good understanding of, there are two classes of the data. There is blue class and there's yellow class. And there is no clear demarcation between the data. You cannot divide this into, if you draw a line like this, or if you draw a line like this, you cannot actually separate these two classes. So it gives you a really, really good understanding to visualize the data so that you can think about what other feature engineering steps you need to do and what machine learning algorithm you need to use. Scikit-learn is also providing a lot of such capabilities in it. So the next step is about choosing the right algorithm. So you have feature engineered the data. Now everything is hunky-dory. You think that you are ready to choose the algorithm. So how do you choose that? Now it depends upon what problem you are solving. If you're solving a regression problem, which is about calculating the probability, for example, or let's say you have property purchase data and you want to find out if I have to buy a 3 BHK flat in Delhi's South Pocket, how much would it cost me? So that how much is basically a number, right? And that actually will tell you that this is a regression problem. So you have some options here, which are like, you can use a linear learner algorithm. You can use decision trees. XGBoost is super awesome. This is one of the most popular or the most prominent winners of most of the Kaggle competitions, which happen every month or every week. XGBoost wins in a lot of them. So XGBoost is super powerful algorithm. You can use support vector machines, and obviously neural networks is also an option. The other type of category is classification category. Probably if you did the first step, the very first step of framing your business problem as a machine learning problem correctly, then this should be a cakewalk. You should already know that which category of the algorithm you need to choose. So if it's a classification problem, you can again choose linear learner, decision trees, XGBoost, k-nearest neighbor, support vector machine, or even in some cases, logistic regression. When we talk about clustering, you remember the unsupervised example which I gave you, where it automatically defines clusters of the customers in a huge data set. So for that, the most popular one is k-means algorithm, which you can use. Apart from that, you have density, centroid, hierarchy-based clustering options as well. And these are all algorithms which are super popular when we talk about industry adoption. So whatever I've included here is basically coming from a lens of what is actually being used in practice in the industry. When we talk about personalization, for example, when you open the Prime Video mobile app or the Netflix mobile app, you get some suggestions, right? Or even if you open Amazon.in, you get some suggestions. So those suggestions are coming from a personalization model. And there are some popular algorithms like factorization machines and heuristic recurrent neural networks, which can be used to build such personalization models. Then there are some more categories like anomaly detection. Natural language processing is a huge, huge field. It is exploding like anything. The example which I gave you, where you type something on your mobile keyboard and it automatically provides you with a suggestion, there is natural language processing happening behind. It automatically predicts what you may be typing next. So this is a huge field which is growing a lot. Reinforcement learning, I talked about it in the beginning, and we have Monte Carlo simulation, Q learning, and deep Q network as one of the few of the most popular ones. For text analysis, it's literally all over the place and it's growing at a rapid pace. So I've just listed few like latent derivative allocation or neural topic modeling. This is again neural networks. This is neural networks. This is neural networks. So you can see whenever we talk about the complex space, everything starts becoming neural networks. Okay, so that's about the algorithms. So how do we actually do that? You need to choose a framework. These frameworks are built on the same concept of the frameworks which you might be aware of when we talk about the Java ecosystem. For example, Spring is the most popular framework out there to build web applications. Similarly, in machine learning world also, we have some frameworks which are extremely popular, and I've listed few of them here. Scikit-learn was actually the first, probably, and if you're starting your ML journey with it, this is the first framework which you might be working with. It's very simple, it's classic, and for some people also think that this is old, but it's still hugely popular. It's very popular amongst enterprise customers, just because it's very simple to use and fast to do. The next one, and the rock star of all, is TensorFlow. TensorFlow is the most popular machine learning framework out there. And I've also mentioned this is the de facto standard in deep learning. When we talk about deep learning, it's all about neural networks. It is created by Google, and it is the most popular framework out there. We also have PyTorch, which is developed by Facebook, and it is one of the fastest growing machine learning frameworks, I can say. It's very intuitive for machine learning developers to use it. It's quite simple, and it's quite Pythonic in nature. You can write your code in a way you write Python. So it's very easy for people to get started on. Caffe is also a bit popular in research areas, but very less industry adoption. MXNet is, I would say, one of the most underrated ones here. It's very optimal, it's super fast, but still it's gaining popularity. It's not as popular as TensorFlow and Scikit-learn and PyTorch. So you can, when you build your enterprise solution, I can assure you that you'll probably be working on one of these frameworks, most probably. Okay, so you have your model trained by using this algorithm and frameworks, right? The next step was hyperparameter tuning. Let me take you back to the diagram. If you are lost, where are we? So we talked about this diagram, right? So we have done the training by choosing the algorithm and the framework. We did the data preparation with the NumPys and the pandas and matplotlibs, etc. Now it's time to do the hyperparameter tuning. So how do we do that? When we talk about hyperparameter tuning, the whole idea is to know when to stop. You remember I put that question in the very first slide. You need to define which is the metric which your algorithm should observe to know that it is done. Otherwise, it will never be done. It will just continue optimizing itself. So you need to tell the model a certain set of parameter values that, okay, take the number of classes as 5, take the number of rounds as 10, take the number of epochs. Epochs is basically the number of times your algorithm sees your data. So you can define that no matter what, you should stop after doing 100 rounds or 100 epochs. It doesn't matter if you get a nice accuracy or not. Or you can also define an accuracy value. An accuracy value is between 0 to 1 for all machine learning algorithms. So you can say that when the accuracy value is around 0.8 or above 0.8, I can stop. So you need to specify this objective function. I need to specify a bunch of hyperparameters. And you see this diagram. This is a DJ console, and this is actually what machine learning does. It basically will calibrate all of these knobs up and down to find optimal setup, which will put that accuracy to 0.8. These hyperparameters will actually do that. So it's quite similar to you equalizing your DJ console or your music console. You want to if you want to have high bass, you might increase the bass parameter, right? So it's your choice what you want to do. You want to have more bass in your sound, so you increase the bass hyperparameter, and that's how this also works. There is no best model. It all depends upon what you want to achieve. Would you want to go for higher precision? You want to go for higher accuracy? You want to go for higher recall? All of these are machine learning objective metrics, which you can read about. But you need to define that metric to actually let the algorithm figure all of that out and stop. So once your model is tuned, then you're good to go for deployment. Now you have run your validation set, and now you just want to deploy the model. So deployment is a bit different than training. And that's why you will see that I have some names like TensorBoard and TensorFlow. These are coming from the TensorFlow framework, but they are still an independent framework in themselves. The reason is when you do training, you need lots and lots of muscle power. You need lots of library. You need lots of memory. You need lots and lots of thread management tools and other etc. things, which actually is provided by TensorFlow. But when you do deployment, you don't need all of that. You just need a lightweight TensorFlow environment, which can provide you with an HTTP endpoint, which you can hit and get your output. That's pretty much it, right? So in that case, that's why TensorFlow and PyTorch have created their own serving environments, which are called TensorBoard and TorchServe, which you can use to deploy your solution and monitor your solution. And if you don't like these two, you can always go to the most popular container orchestration solution out there in the industry, which is Kubernetes. So you can use Kubernetes to build your own Kubernetes cluster, put your model on the Kubernetes cluster, and design an HTTP endpoint and get your output. If you don't even like that, you can go even native. You can go to the Docker, the native Docker solution. You can do everything by yourself. But I would argue, why would you do that in 2020? Why not use a managed offering? Why wasting your effort in managing a Docker infrastructure when you can use either Kubernetes or some advanced setups as well? That's about model deployment. Next comes the model monitoring part. So you need to observe the models for their performance in production to see how well they are behaving and if they need a retraining. You can detect model drift as well. This is the same use case which I talked about, where the consumer behavior starts changing. So the data starts changing and your model's performance starts going down. So from the accuracy of 0.8, it starts falling down to, I don't know, 0.5 or something. And that raises a red flag that you need to retrain the model. Always retrain your model often. I think by now you might have figured that out by yourself by giving multiple examples to you, that you need to retrain your model often, and you need to challenge your machine learning model. Do not play safe. I again would repeat, do not play safe when you are building your machine learning model. Challenge your model with weird data points, with the data which it might have never seen, the data which doesn't make sense. Just throw the data to the model and see how it behaves. For example, if you have built a machine learning solution for your Apple smartwatch, it also has machine learning at the edge, right? It is calculating all that metrics which you are providing to the system. So, I mean, if that solution is built for monitoring the heart rate, et cetera, throw it a financial transaction and see what happens. Just challenge it more. Go wild, go crazy, just see what it does. And that might give you interesting insights into the model's shortcomings sometimes, and you can actually improve those. So the next thing is just to wrap everything I just talked about. So from training to preparation to model tuning to deployment to monitoring, like I said in the very first slide, this is iterative process. So you need to do this again and again. Doing it by yourself, by manual effort, is just a recipe for disaster. You're not going to scale. Your project is going to fail, definitely. You need to automate this. You need to automate the whole data preparation cycle, the whole retraining cycle, the whole monitoring cycle. You can literally automate everything, especially if you're using something like AWS Cloud. You can literally automate all the machine learning steps. And that's what all of the customers do, because like I said, it doesn't make sense to build a machine learning project and not build the ML ops pipeline around it. So you need to build the ML ops pipeline. And there are some popular softwares, again, some frameworks available for it. The most popular one is Apache Airflow. It's extremely popular. It's so popular that Google Cloud has actually adopted this Apache Airflow and wrapped this Airflow around their own managed offering. AWS also has step functions, which also is very popular. So you can choose one of those orchestration solutions which can help you build this whole pipeline. One step connects to another, this step connects to another, and everything happens automatically without any manual intervention. If you're using Kubernetes to manage your workload, then Kubeflow is the new kid on the block. It is being adopted by the Kubernetes community at a very rapid pace, and it is tailor-made for managing your Kubernetes workload and automating those workloads. And if you like a little bit of everything, so you can go for MLflow. And like I have mentioned, it's a jack of all trades. It does all the things satisfactorily well. So this is also something which you can use, and a lot of organizations use MLflow to actually build their MLOps pipeline. And that's pretty much what I had. I think I did wrap it up within 9 minutes past the time. So I will stop the presentation at this point and open the forum for any questions.
Thank you so much, sir, for giving your valuable insight. And now it's time for question and answers. So those who are interested in asking the questions can either raise your hands or write the question in the chat box. Some of you have written the questions. So, sir, I'll be reading the questions for you.
Sure.
So first question is, what are the causes of overfitting? From Sudhan. This question has been asked by Sudhan.
Great. Yeah. So what are the causes? The first cause of overfitting is bad data. You do not have good data which provides you with a balanced representation. The example which I talked to you about, fraud and not fraud, is actually a classic example of overfitting, where you have a lot of positive data points, but you did not have any negative data points which can tell you fraud. So, your model might be performing really well on your training data set, but it falls flat on the validation data set. So whenever you have such scenario, so you talked about the causes. The cause is the data, and if you want to fix it, you need to choose some techniques like lasso regularization and ridge regularization. So L1 and L2 regularization are probably the most popular ones which you can use.
Thank you, sir, for your answer. Next question is, how can we find our machine language model is giving the precise results?
Monitor it. That's the best part. So you have, that's a very good question actually. So you put your model in production, it starts getting, you do inferences, you get the output, and now how do you know if the output is correct or not? The first thing which you generally do is put some sort of a business logic in front of the output. You do not just take the output bluntly and put it to the customer or put it into use. You use that output to apply some business logic which is applicable to your application. For example, if you're building a CIBIL reporting application, if you want to just take all the historical spends of a particular customer and you want to see if that customer is eligible for a loan of X amount or not. So let's say the model said no, for example. So you need to see if the model said no, what are the data points it had. Models also have this concept of explainability nowadays. So model will tell you exactly why it took the decision which it took. Why did it say that it was fraud? So you can take that explainability aspect, apply your business logics on it, and then decide whether it's the right decision or not.
Next question is, sir, where does data mining has its place in machine learning?
Data mining is I would say in the prerequisites, it's definitely not part of the core machine learning space. It's part of the data pipeline space, which I talked about, the blue boxes. So you probably need to do data mining there, where you define data marts, you find the metadata about the data, something similar to data cataloging. When you do data mining, your whole objective is to discover the schema of the data, right? Understand the data. And that is something which you should do right after data lake and between data cataloging, I would say.
Okay, so last question for you is the success of ML machine learning algorithm for NLP based tasks should be dependent on the type of language. Please comment. This is by Dr. Krishna.
So when you say language, you mean the programming language or the language translation language? Do you know?
So I think Dr. Krishna means programming language.
Uh, there is, so when we talk about the machine learning space, generally, programming languages will not be the primary cause of success or failure when we talk about the machine learning solution. I think, for example, the two most popular programming languages in machine learning are R and Python, and both have pretty robust library support. So I'm sorry, but there is there is no clear answer of which programming language will ensure success. I would suggest to start with Python because it has been there in the programming language space for a very long time, and it's one of the most widely adopted language in the machine learning community.
Thank you so much, sir. This ends the question and answer session. Now over to you, Tanu ma'am.
Thank you, Meenakshi ma'am. Thank you so much, sir, for such an interactive, informative, and vibrant session. Kickstart with the fun quest to dragging towards the in-depth knowledge. The way you explain prerequisite for machine language, the way you show the model deployment, machine language operations. That was a how to choose the right algorithm. That was really exemplary. Thank you so much, sir.
Yep, I would really appreciate all the organizers for this and for inviting me to this webinar. I like talking, and that's why I took up this opportunity to share my knowledge. The whole idea is to give you some insights about how it is done in the industries, so that once you actually, especially for the students, once you actually go out of the college and you start working in the industry, you have some kickstart. You know the things. That's the whole intent of this session. Thank you.
Sir. Thank you, sir. Now I request the Honorable Chief Guest, Principal Satyug Darshan Institute of Engineering and Technology, the man of distinct vision and a fountainhead of illuminating ideas, an idol of knowledge and experience and inspiration to all of us, Professor Mohammad Noor Deshmukh, sir, to address the participant. Over to you, sir.
Thank you, madam. It is a great pleasure for me to address our august audience, and I don't have words to thank the speakers all along these 5 days. I hope it has been a very informative 5 days for all. We had at Satyug Darshan Institute of Engineering and Technology, we strive hard to update our faculty members to what is the state of the art in their respective domains, and we also strive to get a right mix of industry and academia, so that our faculty is updated and as well as oriented towards the state of art at the industries, so that our students also gain from that experience. So you might have, I am sure you might have enjoyed, you might have learned a lot in these 5 days, and you might have felt our concern for the distance between the academia and the industry, that we are always looking for opportunities to reduce this distance. And we had people from academia as well as in the industry in these 5 days of lecture series. And the symposium was a grand success, I assume. And I thank all of you for participating, and I also thank my faculty members who had done a lot of hard work in making this symposium a grand success. I congratulate the Department of Computer Science and Engineering, the head of the department, the faculty members, and all. Uh, with that, I would like to again congratulate the department and those present here. And I hope you will be writing your feedbacks, and we will be any organizing has some drawbacks, some lacuna always left. And I hope whatever suggestions come from your end, we'll make amends for the coming organization of such symposiums and programs. I thank you all. Thank you, madam.
Thank you so much, sir. Once a great man said, feeling gratitude and not expressing it is like wrapping a present and not giving it. I would like to request Head of Department, Mr. Kaushal Shakya, sir, for the vote of thanks to our speaker and participant. Over to you, sir.
Thank you, Tanu madam. I think I am audible.
Yes, sir, you are audible.
Okay, thank you very much. Respected and our most distinguished chief guest of the day, Dr. Aman Desmukh, honorable speakers from all days, honorable professors, and our most valued invited guests from USA, UK, Australia, Sweden, Kuwait, Pakistan, Dubai, Saudi Arabia, Nepal, and Bhutan. I deem it a great honor to propose the vote of thanks on the occasion on behalf of Department of Computer Science, Satyug Darshan Institute of Engineering and Technology. I extend very heartfelt gratitude to all the speakers for gracing this symposium with your presence and sharing with us your thoughts on the data science. I sincerely thank our chairman, sir, Mr. S.K. Sachdeva, for kindly accepting our invitation and gracing the inauguration day. I would like to propose heartily vote of thanks to our principal, sir, Dr. Aman Desmukh, for gracing today's event. Thank you, sir, for your very interesting and thought-provoking address. I also wish to express my gratitude to the principal, sir, for his minute-to-minute guidance and support, for providing encouragement at every point of time during the symposium. I would thank you once again, sir, for your moral support and your guidance. We have been fortunate to have some of the eminent persons from academia and industry working in the field of data science and other field of computer science. I am sure that the participants must have been benefited by attending the International Symposium on Data Science. I would like to thank our distinguished speakers for providing us knowledgeable sessions on data science. I would like to thank our speaker of day one, Mr. Chetish Kumar from USA. Mr. Chetish Kumar nicely presented data science and its application in different industries. I thank him for making excellent presentation and making this symposium interesting and meaningful. I would like to thank our honorable speaker of the second day, Mr. Lalit Saraswat, software engineer from USA. Mr. Lalit Saraswat covered topics like modern software development in cloud and paradigm shift in software development process. He used a very elaborative approach to explain data and its stories. His way of presentation was exemplary. Thank you, sir, very much. I would like to thank our honorable speaker of day 3, Professor Dr. K.K. Biswas, an eminent academician from IIT Delhi. Dr. Biswas gave a deep insight knowledge of machine learning, artificial intelligence, and deep learning. A very elaborative explanation was given with the help of various examples. I would like to thank Mr. Ashok Jha from Australia. He nicely explained how data science and AI are going to change the world. Thank you, sir, for your wonderful sessions. I would like to thank Mohammad Nayyar Ali from Kuwait. He nicely explained that how data science is applicable in the modern automobile industry. I would like to thank Mr. Vikesh Pandey, a solution architect from Sweden. Mr. Vikesh Pandey nicely started session with a quiz. He excellently explained machine learning, requirements for machine learning, ETL tools, and other topics of interest. Thank you, sir, for your valuable sessions. I would like to thank all the participants from India and abroad for gracing us with their presence. My thanks also go to all the people of organizing committee and entire Department of Computer Science for their enormous cooperation in the organization of this event. We have been backed by a team of very motivated and dedicated colleagues who know their jobs and are result oriented. In particular, I would like to acknowledge our thanks to the organizing secretary and anchor, Ms. Tanu Dua, for her efforts towards anchoring her own idea and style of explanation of everything. Ms. Swati Hans for nicely coordinating keynote speaker. Ms. Meenakshi for coordinating publication and advertisement. Ms. Ritika Sharma for managing minute-to-minute record of the meetings. Mr. Ashok Madan, Ms. Parul Dhingra, Ms. Nidhi Sharma for well coordination in managing daily sessions. I would also thank to Mr. Salin Anand for providing us online platform for this international symposium. Finally, the wonderful students who have turned up in such a great numbers, not only from India, but also from other countries. Thank you so much for your cooperation. Once again, I thank all for your cooperations. Thank you very much.
Thank you so much, sir. I appreciate the engagement and candor that you all have contributed to this symposium. I personally wish to express my gratitude to you all for joining the session and making it successful. On behalf of our organizing team, I wish you and your loved ones health and safety. Thank you all for joining us. With this, I end the 5-day International Symposium on Data Science. Participants, you are requested to fill the form that is provided in the chat box before leaving.